Hi, college algebra students. This is section 4.4. So we are almost done with all of the new material for our class. We only have this section and then one more short little section called 4.5. And then all we have to do is take test 4, which we will review for, and then prepare for the final. So we are very close to being done. I hope you guys are keeping up in my math lab. Some of you are, some of you aren't. So make sure you're getting that work done. In section 4.4, we are going to learn how to solve exponential and log equations. So we're going to take it one step at a time. First, we're going to learn how to solve exponential equations. So remember, those are the type of equations where the variable is in the exponent. Okay, well, first step, we're going to isolate this exponential term. You want only the base and the exponent on one side. Then your second step, get the variable out of the exponent. Now, this is easier said than done. So there are two methods to get this handled. First method, if possible, get a common base for both sides and then just set the exponents equal and solve. Very simple. Unfortunately, it doesn't always work, which is where method 2 comes in. A little more complicated, but it always works. So in this case, if we can't get a common base for both sides, we're going to take the natural log of each side and bring down the exponent. Now you can also take the log of each side if both the bases are 10, but they usually aren't, which is why we take the natural log. You will need to solve this two ways. One is in terms of ln, and then you just leave it. And the other way is to put it in your calculator and round it to 2 decimal places. So you'll have 2 answers if you use this method over here. Okay? So let's jump right in and do some examples. For the examples you see here, A through D, we're going to solve the exponential equation by expressing each side as a power of the same base and then setting the exponents equal. That's method 1. Okay, well, here we go. I see a base over here of 2 and a base over here of 8. So in order to use method 1, these both have to be the same number. Okay, well, I can't turn a 2 into an 8, but I can turn an 8 into a 2 because we know that 8 can be written as 2 cubed. Okay, so I'm going to leave my left side the same, and I'm going to rewrite this right side as 2 cubed, because that's the same thing as 8. Now I have bases that are identical. Okay, since I do that, I'm going to get rid of those and set just my exponents equal. So now all I have to do is solve that little equation, which is very simple. So I changed these so that I had the same base, and in this case I just made 8 into 2 cubed. Once my bases were the same, I just crossed them out and I set my exponents equal, this side equal to this side. Now I'm going to solve. I get 4x equals 4. I'm going to divide by 4. And x equals 1, and I'm done. So that is how method 1 works, okay? And I was able to do that because I could make both of these have the same base. Okay, let's try this next one. All right, it's kind of hard to tell, but this is the exponent on the 8, okay? Then I notice I have this other 8. Well, I don't see an exponent on him, but you and I know, we've been talking about this, that we can rewrite the square root as an exponent of 1/2. So I'm going to rewrite this. I like to have this big chunk of exponent in parentheses as 8 to the 1/2. Now I have 2 bases that are exactly the same, so they can cancel. And I'm going to set these exponents equal. So I'm going to have x minus 9 over 2 equals 1/2. Okay. So now that they're equal, now I just have to solve for x. Well, I need an LCD to get rid of these denominators. It just so happens my LCD is 2. Now, since they're both the same, you can just cancel them. But if you want a very mathy way to cancel them, I'm going to multiply every top by 2. And when I do that, my denominators go away. And I'm left with x minus 9 equals 1. I'm going to add 9 to both sides, and my answer is 10. Okay? All right, so we're just going to keep doing this. We're going to get a little more difficult every time. I see my next problem here. I clearly see my exponents, but the problem is when I first take a peek at this, I have a base of 9 and a base of 27. And that kind of bothers me because I can't turn a 9 into 27. 9 squared is 81. I've already passed it. And I can't go backwards. I can't take 27 and turn it into 9. But if I think about it, both of these numbers are multiples of 3. So remember, I can write both with a base of 3. So let's think about this. 9 can be written as 3 squared. Then I can just seal it off and put x plus 4 right there at the top. Okay? 27 can be, actually I don't like the way I wrote that. Let's go back and change that. Let's leave our 3 squared, and then let's put this little exponent right there in parentheses like that. So my 9 became 3 squared, and then there's my exponent. Okay, now if I want to write 27 with a base of 3, 27 is 3 cubed. Then I'm going to write this little exponent. There we go. Okay, so now I have a common base. Now I know this looks weird because I have an exponent with another exponent right there. So we'll deal with that in a minute, as long as you're comfortable understanding this part, that we just took each of these and turned them into a common base. Okay, so the only thing that's going to cancel now are these bases, the 3's themselves. Then I'm going to take this whole exponent mess here and put it on the left, equals this whole exponent mess here on the right. There we go. And now I'm just going to distribute. I'm going to get 2x plus 8, and I'm going to get 3x minus 6, and I'm going to solve this. I'm going to subtract my 2x, I'm going to add my 6, and lo and behold, I get 14 equals x. I know I kind of did that all at once, but it's because I was running out of room. But all I did was subtract my 2x. You could have subtracted 3x if you wanted to. I isolated my x and I solved it, and there we go. Okay, part D. Okay, part D, woo, that looks really crazy. I happen to notice here. Okay, first thing I want to do, I want to get rid of this fraction. I certainly do not like that written as a fraction. So let's write this over. We're going to have 4 to the 3x plus 5 equals 256. Okay, and you have a root down here. Not only is he in the denominator, so we're going to have a negative exponent, but he's under a root in the denominator. So you're also going to have a 1/2. There we go. So this 256 raised to the negative 1/2 power is the same as having the root of 256 in the denominator. Okay, now that we have this, it's time to see if we can get a common base, all right? And you can always put this in a little parenthesis if you want to keep your negative there. All right, well, I know that I can't suddenly turn 4 into 256, but could I take 256 and write it as something with the base of 4? Okay, well, 4 squared is 16. Okay, 4 cubed is 64. Guess what 4 to the 4th is? You guessed it, 256. Okay, so I'm going to rewrite this. I'm going to leave this side alone, but I'm going to rewrite 256 as 4 to the 4th. Now I still have that -1/2 hanging around. Now I have the same base, and I'm going to set my exponents equal right over here. So I'm going to have 3x plus 5 equals 4 times -1/2. This is 3x plus 5. This equals -2. I'm going to subtract my 5. I get 3x equals -7. And last but not least, if I divide by 3, my x is -7/3. Okay, and that is my answer. So, method 1, really nice. You make both those bases be the same and you set your exponents equal. The problem is you can't always turn every number into the same base. So let's flip the page. Let's look at page 16. Okay, here we go. Page 16 wants us to practice method 2. Okay, and remember, we're going to need 2 answers for method 2. We need the answer in terms of the natural log, and we're going to then need to put that in our calculator and get a decimal. Okay, and we're going to round that decimal to 2 decimal places. So 2 answers each. All right, so here we go. Now let's look at this for a minute. I think this is a great example of how method 1 is not going to work, because there's no way for me to turn 10 into 24 or 24 into 10. And there's no way for me to pick a multiple of each to do that. So there's no way to make these equal. So that's why we have to use method 2. Okay, well, I have isolated my base and my exponent. Now's the time where I would take the log of each side. Now for these, I'm going to take the natural log of each side. For this one, I'm going to take the regular log of each side. And I'm going to do that because I have a base of 10. And remember, a regular old log secretly also has a base of 10. So I'm going to hopefully be able to work a little magic by doing that and make things easier on myself. Okay, so if I take the log of each side, I'm going to have the log of 10 to the x equals the log of 24. I just took the log of each side. Now, like we said before, there's secretly a base of 10 here. Now, that doesn't help us over on the right. It really doesn't matter if there's secretly a base of 10 here or not. But it does here, because now this base and the base of this are the same. And when that happens, these cancel, and you're left with just the exponent. So this becomes x equals the log of 24. And you're done. Because as long as you have x equals something, you have solved it. So that's our first answer. The second answer is to put this in our calculator. So we're going to take our calculator and we're simply going to enter the regular old log of 24. Log 24. There we go. And we're going to round that to 2 decimal places. So we're going to say x, and I'm just going to kind of make these squiggly equal signs because we're approximating, we're rounding now, 1.38. You don't have to do that. You can write equals if you want to. It's just something that they kind of like. And there you go. Okay, let's move on to B. All right, well in B, first thing I notice is that I'm not even isolated. This is my exponential term, but I have a 7 hanging around in front. So I'm going to divide both sides by 7. I'm going to get e to the x equals 24/7. I can't reduce that, so I have to leave it. Okay, well, I think now it's also pretty obvious I cannot make these bases be the same. I can't turn E into 24/7 and vice versa. So I am now going to take the log of each side. Now, being that my base is an E, rather than taking the regular log of each side, I'm going to take the natural log of each side, because that's going to help me with that E. So as long as you take one or the other, choosing wisely, you're fine, okay? So I'm going to have the ln of e to the x equals the ln of 24/7. Okay, we know this secretly has a base of e. These are the same, so we're going to cancel. And we are left with x equals the natural log of 24/7. Because as long as we have x by itself on one side, we have solved it. Okay, now time to put this in our calculator. See if we can get some kind of decimal approximation. So here's natural log right here. And then I'm going to put 24 divided by 7 there in parentheses. And I'm going to round it to 2 decimal places. And I get 1.23. And there we go. Okay. All right, let's move on to the next one. Okay. Well, gosh, this really looks like we ought to be able to make the bases the same, right? The 2 and the 6. Unfortunately, we can't. We can't go down the other way. And if I square 2, I get 4. If I cube 2, I get 8. It just skips right over 6. I have no way of making these guys the same. So I have to use method 2, okay? Now, I don't have to isolate either one because I don't have anything hanging around in the front. So do I take the log of each side or the natural log of each side? Well, really, it's up to you. You can take either one, whichever one you're more comfortable with, unless the directions specifically tell you, okay? And these don't. This says express it in terms of common or natural. So you can do either one. It really doesn't matter if you take the log of each side or the natural log of each side. So I'm going to go ahead and take the natural log. It's just what I'm used to. It's how I learned it. You can do either one. The answers are equivalent, whether they say the word log or the letters ln. Okay, so I'm going to take, well, this is actually going to be a very long problem, so I'm going to move it up top. It looks like it should be simple, but because we don't have anyone canceling, it's a little more involved. Okay, so I'm going to take the natural log of 2x plus 3, or the natural log of 2 to the 2x plus 3, equals the natural log of 6 to the x plus 1. Okay. Now you might say, well, gosh, how did that help us? That just made it worse. Well, remember the log properties from section 4.3. If we have an exponent and we want it off the argument, remember where we can put it? In the front as coefficients. So now that's what I'm going to do. So now I'm going to put these little parenthesis packets down in the front. So they're no longer stuck up in the air as exponents. That is a huge step, and that would have happened whether you took the natural log or the log, because now we can solve for x and we don't have to try to figure out a way to pull that exponent down. Okay, now we're going to distribute. Now I know this is a little strange the way that it's written. If you want to write it, well, let's think of it this way. What we're going to do is distribute this ln of 2 through the parenthesis. I know normally this is written first like this, you know, and we have this and then we distribute it through this way. I know that's what you're used to seeing, but because we had to make that exponent a coefficient, we're going to have to distribute it through backwards. Okay, So when we distribute this natural log of 2 through here, we're going to get 2x times the ln of 2 plus 3 times the ln of 2 equals x times the ln of 6 plus 1, we don't need 1, ln of 6. And there we go. Okay, so we brought down our exponents, made them coefficients. We distributed our natural log portion through those parentheses. Okay, now let's remember our end goal. The end goal is to get x by itself. So we have two terms that contain x. Let's get them both on one side and move everybody else to the other. So I'm going to move this term over to here, and I'm going to move this term that does not contain an x over to here. Okay, I'm just going to flip-flop that. Okay, so I'm going to have 2x ln 2 minus, I am not going to have enough room there. Sorry, guys. I need my gigantic whiteboard, right? Okay, so I'm going to have 2x ln of 2, I'm going to move this over here, minus x ln of 6 equals ln of 6, and I'm going to move this term over to here, minus 3 ln of 2. Okay, so that's what I did. I moved all terms with x to the left. So this guy went to the left. Now everybody on the left has an x. And I moved this guy who didn't have an x to the right. I subtracted him over here. So everybody on the right does not have an x. Okay? Now, because I want to solve for x, I notice both of these have an x. Guess what I'm going to do? I'm going to pull it out, almost like x is a GCF. So now I'm going to pull out x, and I'm going to have 2 ln of 2 minus ln of 6. There we go. All right, so I pulled out an x. All right. Now, last but not least, I'm going to divide both sides by this parenthesis packet. So what I end up with is x equals ln of 6 minus 3 ln of 2 all over 2 ln of 2 minus ln of 6. Don't get cancel happy on me. You're done. Okay, I know these have some common components, but they're being added and subtracted, so you can't cancel. And now you are finished. Okay, and there you go. Does that make sense? That is a really, really tough one. Okay, I don't have the tests yet from main campus. I'm going to be looking over those this weekend, so I can't really tell you whether or not that's something you're going to have on your test yet, but if it is, we will review it again on the study guide. Okay, so now we're going to have to try to put this monster in our calculator. Let's see if we can come up with an approximation. Okay, I know we got a little bit of a glare there. Here we go. Okay, so I'm going to have the ln of 6 minus 3 ln of 2. That's my numerator, and I'm going to hit enter. Divided by, now I have to use parentheses for the whole thing, 2 ln of 2 minus ln of 6. And I'm going to hit enter. And there we go, 0.71. That's my approximation. Ooh, okay, we did it. I can't even see the last little problem here, but here he is. So let's try to get him a nice line there. All right. Okay, here we go. Well, before we do anything, we need to isolate, just like we did here. We have to isolate because I have this -4 hanging around. I don't want him there. So I want to add 4 to both sides to get rid of him. Okay, so I'm going to have e to the 2x minus 5. I just put parentheses around there. I like to keep everybody together. Equals 24,494. Okay. Now I'm at the point where I need to choose whether I take the log or the natural log of each side. I hope that you're sitting there at home saying natural log, Ms. Holcomb, because sure enough, since this is an e, I don't have corona. If this is an e, then if I take the natural log, it'll cancel. So we're going to take the natural log of each side. There we go. Okay. Remember, there's secretly a base of e here. So remember what happens. Cancel, cancel, cancel. And we're left with 2x minus 5 on the left equals natural log of 24,494 on the right. Okay. All right, here we go. Now I want to solve for x, so I'm going to add 5 to both sides. Now be careful here. Okay, you cannot add 5 to this argument. He's part of the natural log. You can't get in here and mess with him. So when you add 5 to him, he's just going to be stuck on the outside like this. So what you're going to have is 2x equals the natural log of 24,494 plus 5. I put parentheses around him because I didn't want you to think that the plus 5 was part of the argument. You certainly don't have to do that, but I just thought that might make it a little clearer. You cannot combine these two. Okay, and last but not least, we're going to divide both sides by 2. And we end up with the natural log of 24,494 plus 5 divided by 2. And you cannot start dividing anybody because you can't break into that natural log. Okay? All right, we do need to be able to get an approximation. So here we go, natural log of 24,494. I'm going to hit enter. Now I'm going to add 5. Now I'm going to divide by 2. And my x is going to be 7.55. And there we go. Okay, well, you did it. You solved exponential equations. You did method 1 and you did method 2. Okay, now I think that's all that should be in this section, but the textbook goes ahead and throws in the log equations too. So now we're going to look at solving log equations. All right, here's your rules. Again, we're isolating, right? You have to isolate your logs. Make sure 1 is the coefficient of your logs. If it's not, you need to divide by whatever the coefficient is, or you need to isolate the log in some way. Okay, 2 methods here, or actually 2 rules. If you only see 1 log, write it in exponential form. If you have 2 logs, what I mean by that is 1 log on each side, log equals log. You can cancel those and just set the arguments equal. You're going to solve and check your answers because remember, the properties of logs say your arguments must be positive. So if you end up with an answer that makes your argument negative, guess what? No solution. Okay, so we have to be careful with that. All right, well, here we go. First example. Solve the following logarithmic equation. Be sure to reject any value of x that is not in the domain, meaning it makes the argument negative. Okay, give the exact answer. So here we go. Okay, isolate. I'm already isolated. I don't have a coefficient. I don't have anything added or subtracted, so I'm good to go. Now I only see 1 log, so my directions say write in exponential form. So remember, we start with the base, we raise it to the right side and come over the top to set it equal to the argument. Okay, so start at the base, raise it to the right side, equal to the argument. Okay, 2 to the negative 2 is going to put a 2 squared in the denominator, which is 1/4. And you can even put that in your calculator if you want to, and it'll give you that 1/4. So this becomes 1/4 equals x minus 3. Okay, we're solving for x, so we're going to add 3 to both sides. All right, 1/4 plus 3. Okay, what are we going to do about that? Well, let's see. If we have 3 over 1 and we want a denominator of 4, we're going to multiply top and bottom by 4 and we get 12/4. If we add that to 1/4, we get 13/4. And that's our x. Now before we circle it, we need to make sure in our calculator this gives us a positive argument. Okay, so what I'm going to do is come over here and check it. I'm going to take the argument you see here, x minus 3, and I'm going to plug in 13/4 for x. So I'm going to check x minus 3. Okay, I'm going to put 13/4 minus 3 there. You can put that right in your calculator and you get 0.25. As long as you get something that's positive, you're good to go, and it is. So this is your answer. Now, this could also be written as 3.25, right? If you didn't want to write 13/4, just make sure you check your answers and your directions in my math lab, because I'm not sure if they would accept a decimal or if they want a fraction. So just be careful on that. But all I did to check was take my whole argument, I put in the value we got for x, I evaluated it, I got a positive number, so I knew I was okay. All right. Okay, let's look at page 17. Here we go. All right, some more log equations. That's all we're doing for the rest of this section is we are just checking log equations. We're just solving. Okay, well, I'm isolated here. I don't have a coefficient. I don't have anything added or subtracted to the back, so I'm good to go. I also see that I only have one log. So if you just have one log, you're going to rewrite the equation in exponential form. So I'm going to start with the base, raise it to the right side, equals the argument. Okay, well, 2 cubed is 8. Okay, I'm going to subtract 5 from both sides. I'm going to get 3 equals 6x. I'm going to divide both sides by 6. And it turns out x equals 1/2. Now, before I decide that that's great and it's good to go, I need to check. I take my argument and I'm going to put in my x value I just found. 6 times 1/2 plus 5. 6 times 1/2 is 3, plus 5 is 8. That's positive. There's my answer. Okay. All right, well, here we go again. Okay. Oh, this one is very strange looking, isn't it? So first of all, we have a natural log. He is not isolated. This is what should be isolated, just ln of x. So first thing I'm going to do, subtract 4 from each side. That's going to give me 6 ln of x equals 54. Then I'm going to divide both sides by 6. And I get the ln of x equals 9. All right, now we haven't solved this because I don't have plain old x equals 9. So if I have one log only, and even if it's a natural log, that counts, I turn it into an exponential equation. So I need a base. We know it's secretly e to the 9th equals x. And you can leave it like that. That's perfectly fine because you have solved for x. If you were to try to come up with something for e to the 9th, here's your e raised to the 9th. You have this huge long number here. So that is really, really big. So we don't have to do that. We can leave it like this. However, if we are checking our answer, this is what x is equal to, and it's positive. So our argument is positive. So we're okay. It checked out. Okay, next one. All right. Well, I'm isolated. I'm now going to write it as an exponential because I only have one log. I don't see a base, but you and I both know it's secretly 10. I'm going to have 10 to the 0, whoops, equals x plus 12. Okay, what's 10 to the 0? Anybody remember? 1. Everything to the 0 is 1, right? Okay, that equals x plus 12. Now I'm solving for x by itself, so I'm going to subtract 12 from each side. And I end up with x is negative 11. Now, before you say, oh, that's not going to work because our x is negative, that's not the deal. X is allowed to be negative. What's not allowed to be negative is the argument. So if I check the argument, which is x plus 12, and I put negative 11 into that, I'm still positive. So this is a valid answer. So be really careful jumping to conclusions with your answer. Sometimes positive x's won't work. Sometimes negative x's will work. It just really depends on what happens when you plug that value into your argument. Okay? All right, well, here we go. We have a doozy here. Okay? This is actually the last problem that we're going to have with only one log. Now, I know you might say, wait a minute, Ms. Holcomb, that's 2 logs. Well, remember that there are 2 ways to solve these, right? One is if we have 1 log, we write it in exponential form. The other is if we have 2 logs, but it has to be a log equals log situation. This is not a log equals log situation. Now, even if we subtract a log to the other side, we're still not log equals log because we got a 1 hanging around. So this is the problem. This is not a log equals log. So I'm going to have to turn this into a 1 log equation. How do I do that? Well, they have the same base and they're added together, which means what am I going to do to their arguments? Multiply. Remember that? That's from section 4.3. Okay, so we're going to condense this to 1 log. Condense to 1 log. Okay, so here we go. We're going to have 1 log with the same base 5, and we're going to multiply these 2 arguments together, x times 4x minus 1. That is what is going to equal 1. Okay, all right, here we go. Let's go ahead and fix this argument a little bit. Let's go ahead and distribute that x through there. We're going to have log base 5 of 4x squared minus x. There we go. All right, now we have 1 log. So now we're ready to rewrite this in exponential form. So we're going to start with the base, raise it to the other side, equals the argument. Okay, now if we subtract our 5, because 5 to the 1 is 5, from each side. Look what we have there. We have a quadratic equation to solve. So we're actually going to come up with 2 x values, and then we're going to try them both in both arguments. Okay, so now that we're quadratic, we can either factor or put it in our formula. It's up to you. We can do either one. All right, well, let's just practice. We have nothing but time on our hands, right? So let's factor him. Okay, since this is not a 1, we're going to do 4 times -5. We're going to get a -20. All right, my factors for 20 are 1 and 20, 2 and 10, and 4 and 5. And because it's a -20, I know one of these values is going to be positive and one is going to be negative. And they're going to combine to give me the -1. This is going to be it. Okay, so we're going to rewrite this over. All right, who's going to get the negative, the 4 or the 5? The 5. Because remember, if you want a negative, you give the negative to the bigger number. There we go. Now that we have 4 terms, we're going to group. Okay, I see a GCF here of 4x. Pull it out. A GCF here of -5. Pull it out. Same parenthesis packet. Pull that out. And write what's left in the very last one. So we factored. We did it. Okay, if we set both of these equal to 0 and solve, this is going to give us x is a -1. This is going to give us, let's just see if we can do this in our head here. If it's equal to 0, we're going to add 5 to the other side and divide by 4. We get the 2 values. All right, now we've already learned that just because an x is negative doesn't mean it's not a valid answer. So we need to try both, and we need to try in both arguments. So first, let's check x equals -1. If I put it into this argument, well, gosh, all that is x. So this, as a -1, would make that argument negative. So this is not going to work. I don't even have to check that one, because if one of them doesn't work, they're both out. Let's try 5/4. If I put 5/4 in here, sure, that's a positive number. That'll be fine. Okay, so far so good. Okay, let's put it over here. Okay, 4 times 5/4 is just 5. -1 is 4. That works. So our answer, and there's just one of them, is 5/4. Okay, so remember, you have to go back and check the arguments. All right, well, now let's try that other way. Let's see what we can do if we end up with a log equals log. Okay, here we are. We're on example F, and we're on page 18. Let's wait till the focus comes in. There we go. We have focus now. Okay, well, I'm only supposed to have either one log or a log equals a log. Look at this. I have log, it's log crazy. Okay, well, remember, I can condense these to just one log. And when I do, I'll have log equals log. Okay, so let's do that. I'm going to keep this log over here the way that it is. I'm going to condense these over here to one log, same base, which is just the 10. And because this is a plus, I'm going to multiply these arguments. So x times 4 is 4x. Okay, now with log over log, it's really easy because the logs cancel. All you're going to do is set your arguments equal and solve. That's it. It's so nice. Okay, so let's solve. I'm going to subtract my x from both sides. 4 equals 3x. I'm going to divide both sides by 3. and I get x equals 4/3. Okay, before I check it off as working, let's put it in the arguments. Now this argument's a 4. I don't even have an x in there, so he's fine. If I put him in here, that's fine. 4/3 is already a positive number. Let's try over here. 4/3 plus 4. Well, I don't really know what that is, but I know it's not going to suddenly become negative. So that one checks out. All of our arguments are positive. Okay. All right, let's move on to G. Here we go again with the log crazy, logapalooza over here. So we're going to condense these because all I want is log equals log, or in this case, ln equals ln. All right, so here we go. There's an ln. Then I'm going to take these arguments and I'm going to multiply them together. Okay, equals ln of this argument. All right, now that I have ln equals ln, they're going to cancel. This is what I'm left with. This equals this. Okay, let's FOIL this guy out. So he's going to be x squared plus 2x minus 5x minus 10 equals x minus 14. Okay, we'll combine these guys over here. All right, let's move these over to the other side. I'm going to subtract x and I'm going to add 14. That's going to give me x squared minus 4x plus 4. Okay. All right, now we can either factor or we can quadratic formula. Let's factor. We can factor super fast. We don't have to do that strange involved factoring with grouping because we have a coefficient of 1 here. So I'm looking at factors of 4, which is just 1 and 4, or 2 and 2. Okay. Now, because this is positive, either both of these have to be positive or both of these have to be negative. And we want them to add together to be -4. So we're going to use the 2 and the 2, and we're going to make them both negative. Solve, we get x equals 2 for both of them. There's no reason to write it twice. Well, that's a lovely little answer, but before you circle it, go back to your arguments and plug it in. If I plug a 2 into this argument, 2 minus 5, that's -3. We're not allowed to have a negative argument. We can't have it. So we don't even need to check the others. This one would have been fine. This one also would have been negative, but it only takes one negative to mess up the whole thing. So our answer is actually going to be no solution, because the 2 makes negative arguments. So there we go. Okay, well, H and I right there. Okay, there's actually 2 more on the next page and then we're done. Okay, so I see a log and a log equals 4. The 4 is what messes us up. If we added the log over here, we still wouldn't have a log equals log. We would have a log equals 4 plus a log. So I'm going to have to condense these. I'm going to have 1 log with a base of 2. Now this is subtracted, so I'm not going to multiply these together. I'm going to divide them. First one is the numerator, second one is the denominator. And there we go. Okay. Now, because I just have 1 log, I'm going to rewrite this in exponential form. I'm going to start with the base and raise it to the right side equals the argument. There we go. Okay, well, unfortunately now we've got some work to do. We've got some algebra because we are solving for x. So we've got to handle some things. first thing we're going to handle is we're going to change 2 to the 4th to an actual number. So 2 to the 4th ends up being 16. Okay, that helps a little bit. Now, I want to get rid of our fraction. So 2 options. If you're comfortable doing this, because we have 1 item equals 1 item, you can just shoot this right over here and multiply this denominator by 16 and call it a day. Or this is your LCD. So you're going to multiply each side, every term, by x minus 8. Okay, that's what that says over there. Scoot it over a little. It's x minus 8. Okay, that will get rid of this guy. And then here you're going to have 16 times x minus 8 equals x plus 7. Okay, now we have a nice line. We don't have any fractions. Okay, we're going to distribute our 16. 16x minus 16 times 8, which is 128, equals x plus 7. Okay, we want all x's on one side, so we're going to subtract our x, and we're going to add our 128. We're going to get 15x equals 135. Okay, I just put all the x terms on one side and all the constant terms on the other side. Divide by 15. X equals 9. Okay, before I circle it, I have to check my arguments. If I put a 9 here, 9 plus 7 is 16. Fine. Put in a 9 here, 9 minus 1, positive 1. Fine. And there we go. Okay. All right, last one on page 18. Gosh, that looks like almost the same situation here. Okay, so because of this 4 hanging around here, I have to condense these and get 1 log. So I'm going to have log base 2. This is plus, so we're going to multiply the arguments together, and there we go. When you have 1 log, you're going to take your base and you're going to raise it to the right side equals the argument. Okay, there we go. All right, we have some work to do. So 2 to the 4th, remember him? He's 16. Now we're going to FOIL these out. I'm going to have x times x, x times 4, negative 2 times x, negative 2 times 4. Clean it up and subtract 16. That's going to give me a nice little quadratic of x squared plus 2x minus 24. Okay, you can either factor or quadratic formula. Since I don't even have a coefficient up here of anything other than 1, I'm going to factor. All right, I'm looking for factors of negative 24, so that could be 1 and 24. It could be 2 and 12. It could be, oh, I forgot 3 and 8. It could be 3 and 8. It could be 4 and 6. And because I want a negative 24, I could make any of, I'm going to have 1 positive and I'm going to have 1 negative, okay? And I want them to add together to give me positive 2. So I'm going to use 4 and 6. Who's going to get the positive? The 6. Remember, the bigger number gets the sign that you want the middle term to have. All right. So this is going to give me x equals a positive 4 and x equals a negative 6. We're going to check out both arguments. Let's try 4 first. 4 minus 2 is a positive 2. That works. 4 plus 4 is a positive 8. He works. Okay, let's try negative 6. Negative 6 minus 2, that's a negative 8. I don't even have to try him there. He would be negative there too. So I only have one answer. X equals 4. There we go. Okay. Okay, last page. Last page. We'll let that come into focus for a minute. Okay. Come on, you can do it. Well, maybe I'll clean my camera there. Did that help at all? There we go. Now we have focus. Sorry about that, a giant view of my finger. All right, well, my goodness, they went a little crazy here, didn't they? Okay, talk about logs everywhere. All right, well, I can't turn this into log equals log because look who's lurking around the right side. All right, that means all three of these guys are getting condensed into one log with a base of 2. All right, well, I see a plus here, so these two arguments are being multiplied together. I see a minus here. This argument is going to be divided. There we go. Okay, so this was a plus, they multiplied. This was a minus, he got divided. There we go. Okay, now we're going to do exponential form. We're going to start with the base. We're going to raise it to the right side. Equals this whole big giant argument. Okay, there we go. All right, well, let's clean it up a little bit. This is a 4. Let's go ahead and FOIL out our numerator. We're going to have x squared. I'm going to FOIL it out up here. I'm running out of room. X squared minus 4x minus 6x plus 24. I'm going to combine these middle terms. I get x squared minus 10x plus 24. So I kind of did that out of the way up there and did it all at once. Okay, now we want to get rid of this denominator. So again, because we have one term equals one term, you can just shoot it on over there, multiply it over there, make a 4x equals that top and move along. Or my LCD is x, so if I multiply both terms by x, this disappears, and I get 4x on the left equals this numerator. Okay, I'm going to subtract 4x. I'm going to get 0 equals x squared minus 14x plus 24. Okay, you can factor, you can quadratic formula. I'm looking for factors from 24. Remember, we made our list over there on the other page. So they're either both going to be positive or both going to be negative, since it's a positive 24. We want them to add together to give us negative 14. Well, then they're both going to be negative, huh? And they're going to be negative 2 and negative 12. Okay, so we have x equals 2 and x equals 12. Now, before we circle them, we have to check our arguments. Let's check 2 first. 2 minus 6, nope, that gives us an argument of negative 4. He's already out. Okay, let's try 12. 12 minus 6, that one works. That would be a positive 6. Okay, 12 minus 4, that's 8. That's positive, that works. And just 12. All right, we have a winner. That is our answer. Okay. All right, well, last but not least is this crazy equation here. This is a My Math Lab problem. I just don't want us to forget how to handle exponents. It says solve the equation. All right, well, I have 2 to the 11x times 2 to the 9x. We can combine these. They have like bases, right? Okay, and we can add their exponents. So we're going to leave the like base the same, and we're going to add these together, and we get 2 to the 20x equals 32. Okay, now I want to know is there any way that I can make these have like bases? Okay, well, I can't go backwards with 32, but let's think about 2. 2 squared is 4, 2 cubed is 8, 2 to the 4th is 16. Guess what 2 to the 5th is? 32. So I can rewrite these like that. Now that I have a common base, these cancel, and I'm going to set my exponents equal. 20x equals 5. Do not tell me x is 4. Now we're going to divide by 20. X equals 1/4. And there's our answer. And remember, we don't have to check exponentials because it doesn't matter if they're positive or negative. All right, we did it. We survived 4/4. That was the longest. Okay, kids, make sure that you're doing your My Math Lab, and please stay healthy, and I miss you bunches. Email me, text me, call me, whatever you need. I put all my information on Blackboard under the instructor information. So my cell phone is there, everything is there. So if you need me, let me know. And then we are gonna do the very last section of new material, which is 4.5. We're gonna do that next time. And I will talk to you soon. Bye-bye.